Hello, everyone, and thank you for coming for my presentation. I'm Jonathan Leung from Hong Kong. A little bit about myself. I was the R&D manager at a cloud service provider for several years, and currently I'm the head of R&D for DC Connect Global, a telecommunications service provider also based in Hong Kong. I'm in charge of the software engineering team, who is responsible for the SDN and SD-WAN portion of our business. And also, I'm responsible for the migration to an OCP-based network. And I've tried a few different types of network vendors along the way. So I'm going to share my experience in this presentation. And so that's the title of my presentation, Transition to an OCP Infrastructure in a Telco Environment. And this is the agenda. First, I'll give a brief summary of what is DC Connect and what is it that we do. I'll also explain in more detail some of our technical requirements that OCP can help fulfill. Then I'll talk about our original state. Here, about the original vendors we used in our SDN network, and also what was the problem that led DC Connect to explore the transition to a white box infrastructure and a Linux-based NOS. I'll talk about the transition and the current state. How did DC Connect implement and deploy this technology? Afterwards, the future state. Where would DC Connect like to go next? And finally, the call to action. How do we get there together? So let's start with the first topic. What is DC Connect? DC Connect is a Hong Kong-based carrier and MEF member that has built orchestration software to help other telcos convert their legacy business to an overlay-based SDN network. And we have hired talent from all over the world, including the US, Canada, India, and in China. So we're focused not only on delivering connectivity in Asia, but also internationally. As mentioned, we're a member of MEF, or Metro Ethernet Forum, which is a consortium of telcos and other networking companies that is focused on carrier Ethernet services. Carrier Ethernet alone is an $80 billion industry, and MEF already has over 650 service providers, so DC Connect is well positioned to help introduce OCP concepts to other telcos. And this is important because we want telcos to use OCP and become more open and more software enabled, which they can do by using our platform. Once that happens, then we can integrate with them through the East-West APIs and extend our service coverage by tapping into their networks. And they can do the same for us. So that's a win-win for everyone. And also, our orchestration platform will connect northbound to the portal, and southbound to our control plane, and as mentioned before, east-west to other telcos, using the Sonata LSO API standardized by MEF. So a bit more about us. Our SDN platform has the following key features. We will deliver fully automated carrier Ethernet service through a self-service portal. We have connectivity to over 120 data centers in Asia and in the US. And we also have 100% of the 30 major data centers in Hong Kong. We have our own set of APIs to do interconnections with other carriers, and we have already integrated with other carriers' API, which is how we are able to gain access to data centers all over the world, like in the diagram above. We've also integrated with some cloud providers like Azure, AWS, and Alibaba, so we can provide data center to cloud or even cloud to cloud services. So we have a self-service customer portal, which consists of OSS and BSS functionalities. So we have a lot of different features. We have the network orchestration, the pricing inquiry, the service coverage. We have some admin functionality for managing the customers, the devices, the pricing, and also the white labeling functionality to change your logo or your colors and other brand elements. Network operators can also use the portal to visualize the network. So this is just one of the many types of visualizations that we provide. It shows all the connections originating from a single port on a leaf switch. Each flow is a connection, and the width of the flow represents the bandwidth of that connection. So from left to right, you can see the flow from leaf to spine to leaf. And finally, on the very right, we show the city of the destination leaf switch. So it's thanks to OCP and SDN that we have this very good visibility over our network. In order to enable telcos to provide carrier Ethernet service over SDN, we have quite a lot of requirements. This is the VLAN requirements. We have to automate the layer 2 overlay between provider edge devices over an existing underlay network. We have to do the point-to-point and the multi-point connectivity. And then we need to support VLAN tag transparency, 802.1q VLAN trunking, Q-in-Q double tag trunking, and every endpoint could have different combinations of the VLAN tags. So we also have to support the VLAN translation. So it could be single tag to double tag, it could be a no tag to double tag. So we need to do push and pop of double tags simultaneously. So this is an example, a VXLAN overlay with many different points. So on the left at the bottom, you could see there is a customer edge with untagged traffic, and then there are two CE devices with CVLAN 100, a CE device with CVLAN 200, and then the NNI switch with a S and a CVLAN. So that's a double tag. And all of these endpoints are connected over the same VXLAN overlay, and they can all communicate with each other. So these are our automation requirements. We need to support full automation and monitoring of layer 2 overlay tunnels. So given only the client parameters, such as the ports, the VLAN tags, and the bandwidth, everything else, such as the VXLAN number, how the path should be routed, that is decided by the system. We have to support all the CRUD operations, create, read, update, and delete of the tunnels. So our connectivity service provisioning has to be measured in seconds, not days or weeks, because in a legacy telco, a network engineer would have to manually go to the data center or type the command line, and that may take a long time. With automation, it should only take seconds or minutes. Lastly, we have the bandwidth monitoring for anomaly checking and failover. This is known as the K shortest path with least overlap problem, which means we are trying to find at least two, free is better, different paths through the network. In the diagram to the left, we have a primary path and a secondary path, which is in blue. And you can see there is no overlap between the paths. So that is good. And if the primary path fails, then we will automatically fail over to that secondary path. So, and these are our requirements for the scalability and interoperability. First, we will use VXLAN instead of VLAN because there are a total of 16 million possible VXLAN numbers opposed to 4,096 VLANs. The system also needs to be scalable because we have 120 POPs alone, and our telcos often have way more than that. To reach the greatest number of different telcos, we need to support multiple vendors and eventually become vendor agnostics. So it doesn't matter if one end is Cisco and the other is Cumulus. We should be able to interoperate between all of these different brands. We need to support multi-cloud connectivity. As I said before, we have AWS, Azure, and other clouds. And these clouds can connect to each other, even though they are different cloud providers. And we have multiple carrier connectivity through an API standard that allows us to leverage other carriers' networks, as well as they can do the same for us. Now let's talk about our original states before transitioning to OCP. DC Connect has all those 120 POPs using H3C switches running a COMWare 7 OS. So COMWare 7 actually used to be a part of HP because HP had a majority share in the company H3C, but in 2015 they sold off that share. So a lot of these switches that we bought, H3C switches, they're rebranded HP switches. And moving on, so those switches are managed by an SDN controller developed by H3C, which they call AD-WAN. This met our immediate need to hyperscale our network by programmatically creating and managing VXLAN tunnels. So it was able to meet our VLAN requirements and our automation requirements. However, it was not able to meet our interoperability requirements because the software and the hardware are both proprietary and integrated into the switch. We can't decouple them. And that's just part of the problems of our original state. First, we have the vendor lock-in to H3C and their proprietary controller. This is a single vendor solution, which is a similar problem if we had deployed Cisco and also the Cisco controller. What happens is we are writing code that is not reusable between different platforms. So we want to support as many vendors as possible, but if we need a different code base for each vendor, that's not scalable. Also, there's a limited feature set and a limited API, and an inability to develop new features and a limited support in getting new features and updates from the vendor. So if we want new features, we need to ask the vendor for that feature, and then they will provide it to us, or maybe they won't. Maybe they will say next year, or it's in the pipeline, and we don't have much say in it. When we first decided to move to a more open architecture for our SDN network, our first consideration was Brocade OpenFlow switch with Viata NOS. The SDN controller is Brocade, which is a commercial implementation of Linux Foundation's Open Daylight project. Open Daylight, of course, is open source, and so is OpenFlow. So this seemed like a good idea. But what we found in practice was that OpenFlow was too low level for our needs. OpenFlow basically replaces all the existing routing protocols by introducing a NeoFlow-based mechanism, which can replace BGP and OSPF. Now, this is very good if you have a use case that the traditional protocols can't solve. But since what we are doing is we're helping telcos move from a traditional network to SDN, the traffic is still using the traditional protocols, and we can't just break those. We also found that there's a lack of support from Brocade, so stability was an issue. We found that it did not feel production ready because of lots of bugs, and not long after, Brocade was bought out by Broadcom, which I guess explains the lack of support. So I think there's definitely a case to be made for using OpenFlow. Like for example, Google is using it in their Jupyter data center network, but they also designed their own switches and they don't need to interoperate with other vendors' devices or other networks. Now we move on to the current state. After reviewing various NOS, DC Connect chose Cumulus Linux and Edge Core switches for our next generation SDN platform. By choosing Cumulus, we were able to decouple the software from the hardware and choose from different hardware vendors such as EdgeCore, FS, and Dell, and while maintaining the same software interface. So compared to before, this is much better. We are now able to have multiple vendors, but we don't need multiple code bases. So there was a bit of a learning curve from moving from H3C to Cumulus, because Cumulus now uses a completely different Linux interface versus command line interface. However, Cumulus was able to support us and provide us with a sample network topologies and Vagrant scripts. And that brings us to the other advantage, which is to allow developers to control the switch using something that they know very well. They're very familiar with Linux. So they can use any tool they want, like Ansible or Vagrant for simulation, monitor network traffic and performance using iPerf and BWM. And so in the end, we were able to use Ansible to control the switches without a need for proprietary controller software. In contrast to the traditional SDN controller, the controller actually becomes a thin layer. It's almost stateless, unlike OpenFlow or the AD-WAN solution that we used. It transforms the intent, which comes from our orchestration system, into Ansible Jinja templates and runs them. So for example, the intent could be from Hong Kong to San Jose with VLANs 100 to 200, and the bandwidth is 250 Mbps. And that intent turns into a Cumulus configuration. We just need to plug in those numbers. Since Cumulus Linux is the Linux, we can also install the controller on the switches themselves. That makes it basically a distributed system and a high redundancy system. Now that we are using Linux, we can control those switches, and we can also provide features that we were not able to provide before, such as something called recovery on demand. And here we provide a secondary circuit for another telco's primary circuit. And it starts up automatically once we detect that there's an issue with the primary circuit, which will cause traffic to be diverted to our secondary circuit. And this lets telcos try the SDN without any commitment at all, because they're not even using, their primary circuit is still manual or using their old system, but the secondary circuit is using our system. As well, we also have a product called AutoMesh, which provides a multi-point connectivity with a shared bandwidth cap between all endpoints. The bandwidth is automatically allocated to each endpoint according to their usage. So an example here, let's say the total usage shared among all the ports is 300 Mbps. So that's how much the customer is billed, 300. It's a fixed amount and shared between three interfaces. So by default, you will have a 100 and 100 and 100 Mbps distribution. But let's say we have more traffic on interface 1 than interface 2 and 3. The ratios will be changed. And actually, we will do auto scaling and we will automatically apply more bandwidth to the first interface. So for example, 150 and less to the remaining interfaces. And if interface 2 had a spike, then the distribution might change. It might be 75, 150, 75. So our current state is very good, but there are still a few problems with it. The middleware or the driver that interfaces between the hardware ASIC and the NOS is still proprietary, and it must be designed to the manufacturer's specification. So this is like the special sauce or the black box that allows the white box NOS to run on multiple vendors' hardware. Because sometimes you may have to sign NDAs with the manufacturers to make the middleware. So you can't always have it open source. Switching could be implemented completely in software that will bypass the issue. But that also means we won't have enough performance for the hyperscale network. And also, we have some telcos that are using existing or legacy H3C devices. And that means our controller or automation system has to be able to control both brands simultaneously. And maybe we will also support more brands. Just like Cumulus or just white boxes is not enough. And so looking to the future now, we look forward to the development of the vendor-neutral open standard for ASIC APIs. Just as MEF has standardized the carrier Ethernet and SD-WAN services, an OCP standard on ASICs will lead to greater adoption by carriers and increased interoperability. It means that any manufacturer could create an ASIC that complies to the specifications, and any network OS built against that Open API can be used with any compliant ASIC, which fully decouples software and hardware. So one thing that we're very interested in is we're looking at the progress of OCP's SAI initiative. And we hope that this will be the gold standard for all the manufacturers to follow. So we believe that the SAI project will result in open ASIC standards, and that will spur innovation in the network industry. It will allow more competition and growth on both the hardware and the software side. On the hardware side, vendors can continue to innovate on performance while maintaining compatibility with all the existing NOS or network operating systems. And that minimizes the risk of obsolescence. On the software side, the software vendors can benefit from the same hardware innovations without having to significantly modify their software. So that minimizes vendor lock-in and also encourages code reuse. And so to conclude, we believe that what OCP is doing will have a great impact on the carrier industry. And we hope to show other telcos that using OCP infrastructure can deliver great benefits to their network, and at the same time, reduce their CapEx and OpEx. So for some more product information, DC Connect offers the full-featured global SDN with a focus on Asia data center and cloud connectivity. Our products include the SDDCI, SD Cloud Express. So these are software-defined, on-demand data center to data center connectivity solutions, or data center to cloud, or even cloud to cloud. We also have the recovery on demand and auto mesh that I talked about earlier. And of course, all this is made possible by our DC Connect's orchestration system. And if you want to learn more information about our transformation to OCP, or if you have a question about our products and what we do, please reach out to alliance@dcconnectglobal.com for more information. All the products listed on the previous slide are currently available right now, and additional information can also be found on the links below. And that is all from our side, so thank you for listening to this talk.
Okay, yeah, hello everyone. And sorry for the technical difficulties. I'm Jonathan, and Michael my head of solutions, will also be here to answer the questions. So.
Yes, good morning, good evening, good afternoon.
Yep. And that's Michael. So let's see, we have a question right now from Peter Lam. The first question is, what was the most difficult part of the transition from the traditional switch to an OCP white box switch? Number two, what kinds of milestones have you defined when moving from the traditional hardware and NOS to OCP equipment? Okay, so I'll answer that. So for the first question, the most difficult part of the transition from the traditional switch to the OCP white box switch, I think it will be for our engineers to relearn the iOS-based networking CLI and embrace Linux CLI. So we use Cumulus now, and Cumulus provides a CLI that is kind of similar to iOS. However, to take advantage of Cumulus, we have to use the Linux CLI, so we can do automation using Ansible, or we can use other tools like Puppet or Chef. So we really need to switch into the DevOps mindset when doing the network automation. And so we can just, update the Linux configuration files and change the whole network instead of going to a single interface and updating the interface one at a time. And for the second question, the kind of milestones that we have defined. So because we started by using some switches from H3C, so we already know, what kind of features we want to support. So the first milestone is to have a proof of concept to verify that the Cumulus or the OCP equipment can do everything that our existing switches could do. So that's by setting up the lab and doing the reproducing all the functions of our existing switch with Cumulus. And then once the second milestone will be to generalize the Cumulus commands so that we can do automation. So that involves writing Ansible Jinja templates and Python scripts to automate the commands. So we parameterize all the interface numbers. So we just need to enter a parameter like interface switch port 1, and then that will be updated. And lastly, we need to provide the automation functions as a REST API for our orchestration and BSS OSS to use. So as I mentioned before, we have built a self-service portal that will call those automation functions that we have already defined. And so once we have the API for that, then we can perform the full user acceptance test. And then everything is make sure everything is properly integrated. So those are the kind of milestones that we did from the transition from the traditional to OCP switch. Okay, and so there are also some questions from Rajiv. So I will answer them in order. So I think the first question is to elaborate more about the SDN that we use. Okay, so as mentioned in the presentation, we are not using Open Daylight now. We are actually using the Cumulus Linux. And we have written our own control plane layer using the Ansible and other DevOps tools in order to support all the features of Cumulus.
And this is Michael, and I can expand on, Rajiv's other questions about, how we use the APIs to integrate with the other providers. Or Jonathan, would you like to continue on some of the other points that Rajiv made?
No, go ahead.
Sure. So what we do for the API integrations is our portal is able to go out and look at all the other carrier partners that we work with, such as Packet Fabric, Council Connect, and Megaport. And over the RESTful API, make a call to pull a list of all of the sites that they have as endpoints, populate them into our system, and then once they're in our system, our customers have the ability to order circuits from A to Z, whether those points lie on our network or not. And depending on the partner, services are typically deployed within about 30 to 90 seconds. And that API is also based on the MEF Sonata standard. I see we have a few folks from MEF on the call today, so would like to state how much we appreciate the support and continued support from MEF.
Yep. So so moving forward to Reggie's other questions. So he wants to know if the self-service tool can find any Ethernet service issues and fix it in advance. So as mentioned in the presentation, we have a product called Recovery on Demand. So this product basically acts as a backup circuit for your existing circuit. So even if you have a traditional circuit that is not SDN, we can provide a backup for that. So we can detect when there is a failure, and then if there's a failure, it will reroute to our SDN network. So that is how we can fix those Ethernet service issues. Yes, and Michael has answered the questions regarding the APIs.
And I can now answer Steve's question about the CapEx, OpEx save. So it's hard to quantify in exact dollars and cents the exact savings that we've made because this product is very much in its infancy to a certain degree. We launched DC Connect about 2 years ago off of the software development work that was done at the previous company that Jonathan mentioned. So what we have noticed by moving to this model, the CapEx expenditure tends to go down a little bit because you have no vendor lock-in and you can have multiple vendors compete on an RFP for the actual hardware. And then from an OpEx standpoint, there's much less engineers required to operate the network. So from cradle to grave, our system handles quoting, ordering, provisioning, monitoring, troubleshooting, and resolution of any issues. So it's really a fully meshed BSS OSS system for managing the telco network.
Okay, so we have another question from Peter. What is your motivation for using the open source software? So I think one of our motivations is to increase the speed of the feature development to meet customer demands. So by using, because we were using the vendor's manufacturer's software before, we are tied down by the manufacturer solution, which is supported by them. But because the manufacturers, they will decide, they have their own pipeline, right? And we are not able to, perhaps there are some features that we want and they will not deliver it until, maybe years later or never at all. So by moving to this open source software and by also building our own control plane using the DevOps tools, then we are able to be very agile and very quickly develop new features as the customer requires.
Yes, and that's the real beauty of working in the open source environment, rather than having to wait for the vendor to actually develop the feature set that we want. We're simply working on a Linux box, and we can develop those features on the fly. And I can also address Rajiv's other question about our portal. So our portal allows for the full quoting, provisioning, and ordering of services, as well as the metric reporting. We should have filmed a bit more of a portal demo, but what our portal enables is full access to our 140 plus POPs in mainland China, 30 POPs in Hong Kong, and then over 5,000 different POPs from our carrier networks or carrier partner networks that are all pulled in and aggregated in one place. So you could order a service from a Beijing data center all the way to Equinix Ashburn, just with a few mouse clicks. And the pricing is very competitive. We don't lock our customers into long-term contracts. You can take services on contract as low as 1 day or hourly, depending on the partner we're working with. If it's all on net for DC Connect, we allow hourly contracts. So in the event you've released a new piece of software or you've had a database failure and you have a requirement to up your bandwidth between 2 points for data replication, that can all be done on the fly and be done very quickly.
Yep. So for Peter's other question, so assuming the open source software refers to the NOS, so we are already using Cumulus Linux in production, using the edge core switches. So that part is already in full deployment in production. As for other NOS, we are in the process of evaluating a SONiC. So we're looking at whether the SONiC can meet our requirements like the VXLAN tunneling, the multi-point networking, and QNQ that were mentioned. And we will, so we will probably do maybe a POC in the lab environment later this year, because we're very excited to see, take advantage of SONiC to be able to run the same NOS over different hardware vendors. So I can say we are already using the open source software in production, and we are also evaluating some other open source NOS.
Are there any questions from the community that you would like to see answered? If so, please submit them in the box, and John and I will be very happy to answer them for you. All right, if there are no further questions, we'd like to thank everybody for their time, to get on the, some more questions popping up. Nope, okay. We'd like to thank everyone for taking the time out of their busy day to get on this webinar and learn a little bit more about how we've implemented OCP bits and pieces in our network to try to make our system more user-friendly and make it easier to interconnect with other carriers. We're very keen on, pursuing what we have going with Cumulus, and also looking into the developments that are coming with SONiC, as well as the switch abstraction layer that are all led by OCP. So very excited to work more with OCP and the community, and humbled by the chance to be able to do so. So thank you everyone for your time. If you have any more questions, Jonathan's email is attached to his speaker bio, and I'll make sure that my information gets sent out as well. So any questions whatsoever on our platform, please feel free to reach out, and we will expeditiously respond to your questions.